In this project, we will simulate a plate silencer and sound absorption mechanism. The present model is designed in 2 dimensions using design modeler software. The model has a symmetrical structure whose middle wall has a sinusoidal and wavy structure. Adjacent to the airflow inlet boundary, a section is defined as the source of sound wave propagation. The wavy plate is drawn in such a way that has a wave amplitude of 15 millimeters. The meshing of the model has been done using ANSYS meshing software, and the mesh type used for this geometry is structured.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by Mr. CFD. Or if you are watching the training video, click on the Mr. CFD logo and subscribe.
By clicking on check button, you will see that under the console tab, the Fluent software will start to check your mesh for any errors. Now, as you can see in this window, there are 2 receivers defined in our project. The first receiver is in the inlet section near the source of the sound, and the second receiver is at the outlet section. Now, the reason behind defining 2 receivers is that we want to compare the frequencies and sound pressure received by these 2 receivers, and thus observing the efficacy of the muffler. Now, in the appeared window under the Momentum tab in front of the Velocity Magnitude section, you can see that the velocity magnitude of the airflow entering our inlet boundary is equal to the value you can see in this window. In this slide, after double-clicking on the Run Calculation button in the appeared window, you define the number of time steps and the time step size, as we had selected the time step size equal to 0.5, just like the paper. And we had defined max iteration of 20 per each time step. After defining these values, by clicking on Calculate, the software will start the simulation process. Now, in this contour, you can easily see the pressure changes along the axis of our geometry. Now, in this contour, you can easily see the velocity distribution inside our computational domain. Now, this recurring increase and decrease in velocity will have the result of energy depletion of the airflow. Now, as was previously explained in previous slide about the recurrent increase and decrease in the velocity along the axis, you can easily see in this plot the changes of the velocity. Now, as was previously mentioned again, you can see that this recurrent increase and decrease will have the effect of energy depletion of the airflow. In the appeared window, under the y-axis function, we select sound pressure level, and under the receiver section, you can select between 2 receivers. After that, by clicking on Plot FFT button, the software will show you the diagram of the sound pressure level in terms of frequency for these receivers. As you can see in this diagram, the receiver at the outlet section has clearly received lower sound pressure levels comparing to the receiver at the inlet section, which shows that our muffler is effective and it has lowered the sound pressure levels. Now, in this diagram, you can see the difference of the sound pressure level of the 2 receivers for different frequencies. In this diagram, you can see that our muffler has worked and has caused a constant decrease in the sound pressure level received by the 2 receivers. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
A muffler or silencer is a device for reducing the noise emitted by a system. Mufflers are installed within the exhaust system of most internal combustion engines. The muffler is engineered as an acoustic device to reduce the loudness of the sound pressure created by the engine by acoustic quieting. The noise of the burning hot exhaust gas exiting the engine at high speed is abated by a series of passages and chambers lined with roving fiberglass insulation or resonating chambers harmonically tuned to cause destructive interference, wherein opposite sound waves cancel each other out. The present problem simulates the sound pressure waves absorbed by a plate silencer using ANSYS Fluent software. To simulate and analyze sound or acoustic waves, acoustic model has been used in the software. In general, mechanical waves within a fluid are caused by the vibration and reciprocating motion of the fluid layers. For example, when a layer of air moves forward in a certain direction, the next layer of fluid pushes itself forward and the layer itself returns to its original position. These reciprocating movements of the air layer must continue until the energy within the airflow is depleted. Now, if this number of reciprocating movements reaches more than 16 times per second, sound is produced. In fact, when we heat the surface of the solid subject with our hand, the layers of the air between our hand and the surface began to move back and forth. If the number of these round trips is more than 16 times per second, the sound is produced by our hand hitting a solid surface. But one of the problems in various industries is the production of very low and abnormal sounds due to the propagation of sound waves. Therefore, in such cases, the use of silencer seems imperative. The basis of the working mechanism of these mufflers is that by receiving sound waves of the environment, the silencer starts vibration. Finally, the sound wave and the silencer components' mode shapes equalize, and this causes ambient sound waves to be absorbed by the muffler. To perform such steps, the plate silencer has some plate inside itself. By adapting their mode shapes due to the vibration caused by the sound waves, the plates absorb the sound. These mufflers are used in various industries such as metallurgy, power, mining, etc. The material and the type of design of the silencer are such that they can absorb the sounds produced with different frequencies and in the range of human hearing from 63 to 800 Hz. They can provide the condition of environmental comfort in terms of the sound. Simulation and analysis of this silencer is of great importance because if designed incorrectly, the muffler will not only not be able to absorb sound, but it also may increase the sound. In the present project, a plate silencer is modeled with a symmetrical structure that has a sinusoidal or wavy plate in the middle of its body. To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.